And welcome back. As we go ahead and look at some programming examples, we're going to go ahead and look at an application for a hash table and also with binary search trees. So what I've gone ahead in is I have a demonstration of a hash map structure. This is actually something that is part of the Java packages. I just have to import it, java.util hash map. And this is actually going to use a structure that we can use to actually put things here into a hash map. You can see we have a very simple demonstration here. And if I look at the class, you can see it is using an array to actually handle that implementation. Now, of course, there's some other classes and stuff that have to be imported, but it is going to be nothing that is super complicated. So we have a for each loop here that is simply saying for each integer in the array, we're simply just going to put that integer .toString into it. So you can see we have a little bit of conversion here using a wrapper class. And we, of course, then here have a for loop that is going to get that map key set. Now, what this, of course, does, this half right here, allows us to actually print what is inside of that hash array. So when I look at that and I call insert and print, of course, is this method here. I could separate this out. I could, of course, just make this the insert part of this, and I could make this the print part. That wouldn't be hard to do, but in this case, we have one method that's simply just encapsulating both of that. When I look at my binary search, there's a little bit more here to actually pick apart, though. With a binary search method, one of the things you'll notice is we still have a node here, which is, of course, something that we're used to operating with. We, of course, have our left and right nodes that we would expect to have. And when we create a new node, of course, we are creating temporary values here for the key, and in this case, the left and right. And down here is our options to insert. Of course, we see, hey, if this tree is empty, we're just going to create a new node. Otherwise, if it is not, we're going to use some recursion to go ahead and traverse this tree to go ahead and start adding either to the left or the right, depending upon where that key is being placed here. Then we have, of course, some actual methods to use this tree. So it's one thing to build it, but we need to be able to use it. So this allows us to search the tree to go ahead and see if there is a value within it. So this, of course, is looking to see, hey, this is the root of it. And this, of course, if it is greater than the root key, it's going to search here. If it's smaller, it's going to use this one. We also, of course, have the option to delete a node, which is very helpful because if we need to remove something out of that tree, this allows us to do that. And you see there's quite a bit that goes on in here to actually make that happen, because when we delete a node out of the binary search tree, we actually have to update it such that it's going to point to a new location, because we're effectively restructuring every branch of that tree. Then we have a couple different examples here of traversals. Now, the most common one is the in-order traversal. But then just so you can go ahead and see how they might be different, we also have a pre-order traversal and a post-order traversal, just so you can see how those might differ. Now, if we go ahead and look at our main program here, you can see that what we are doing is we, of course, are creating our binary tree structure. We start by initializing that root to null. And then what I'm going to do is to actually add values. I'm just going to insert, and that will allow me to actually put values into this tree. And then, of course, we can do some tests here. So here's a in-order traversal. Here's a pre-order, our post-order, and then a demonstration of us if we delete that node and how that looks, and then if we search for a value. So let's go ahead and give this a run just to see how this looks. And one of the things you'll notice is when we do the hash table, I've, of course, having this print out, separate each value by tabs. Then we have our binary search tree right here. And this is, of course, showing the in-order traversal, our pre-order traversal, our post-order traversal. And then, of course, this down here is our returning results for if we need to delete and traverse things. So again, a pretty cool, quick way for us to kind of traverse through this system here. So it allows us to see some examples here, again, with the hash table and with binary search.